Today we'll see all about mean. The average of n observations is called mean. That is, mean is equal to sum of all the observations divided by number of observations, or we can say total number of observation. It means that this is just a simple average, right? Whenever our data is very small, directly we can use this formula. Mean is the most frequently used measure of central tendency because it takes into account all the observations. See here, in mean, all the observations we are taking, correct? That's the reason here we have written sum of all the observations. See here, so every observation we take in account. Okay, here, mean for ungrouped data. There are two types of data. One is ungrouped data, another is grouped data. So whenever ungrouped data is there and the data is less, that time we will use the following formula. Let us consider here. Our observations are x1, x2, x3 and so on till xn, right? So if we want to find out the mean of that, we'll write down x bar. X bar, it means that mean, which is equal to sum of all these observations divided by n number of observations. See how many observations we are having? N number of observations. So we have written here n. So sum of all the observation, it means what? Summation of xi. I means what? It will vary from 1 to n, maybe 5 observations, maybe 1 to 10 observations, maybe 1 to 15 observations, like that, divided by n. So instead of the previous formula, even we will use this formula. That is okay, right? Let us see one example here. Find the mean of the data. Data is given as 10, 30, 50, 20, 40. So here, this is the formula written here, which is equal to sum of all the observations divided by total number of observations. How many observations are there? 5 observations are there, correct? So here sum comes as 150 by 5 and mean is equal to 30, right? Now see, mean for, once again I have written here ungrouped data. Now in this case the data is little bigger data, right? Bigger in number. So here, if our observations are x1, x2, x3 and so on till xn, with respective frequencies f1, f2, f3 till fn, then this means x1 occurs f1 times. That means first observation occurs f1 number of times. x2 occurs f2 times and so on. That means when we want to find out the mean, what we'll do? f1 x1 plus f2 x2 so on till fn xn divided by sum of all the observations, means what? Sum of all the frequencies here. In short, summation of fi xi divided by summation of all the frequencies. That means summation of fi, correct? Now let us see it. With the example, you will get little more clarity. Here, find the mean marks obtained by 25 students in mathematics paper out of 100. So in the table, the information is given. Here see, 5 students got 50 marks each. That means there are 5 students in the class who got 50 marks each, right? Now one student got 33 marks, 4 students 38 marks each, right? This way the information is given. Now let us find out the mean. Here, the same table I have written here, but in this case one more column I have added, that is fi xi. So instead of adding 55 times, what we did? 50 into 5. And then we got the product here. This 250 is nothing but what? 55 times. So 50 plus 50 plus 50 plus 50 and plus 50. Right? Instead of writing in the addition format, we did the multiplication here. So 31 into 1, which is 33 here. 38 into 4, that means 4 students got 38 marks each. So 38 into 4 we got this number. Same way we got these numbers, and finally we did the addition, summation of fi xi, and this 25 is the summation of all the frequencies. It means that the total number of students are 25 here. To get the mean, the formula is this. X bar, it means that I already said it is mean, which is equal to summation of fi xi divided by summation of fi. So here 1530 by 25, our answer comes as 61.2. Therefore, mean marks obtained is 61.2. Right? Now come to the another type of data. There are three methods to find mean of grouped data. See here. Now already I told you two methods to find out mean of ungrouped data. Now our data will be grouped. That means data is distributed in the form of groups. See here in the table here, 0 to 10, one group, 10 to 20, another group. These groups are called as class intervals also. Okay. Now for the direct method, same formula as the previous one. Only what is the difference? In this case, the groups are there. In the previous case, groups were not there. Correct? Now, let us see how to get the answer of this question. Here, class intervals same I have written. Frequency also same I have written. But in this case, in one of the column, I have written class mark. Class mark, it means that upper limit plus lower limit divided by 2. That means it is the average of a class. So this 0 to 10 is a class, and class mark of this class is what? 5. 0 plus 10 by 2 is 5. This 5 is representing this class, the middle value of this class, right? Because in 0 to 10 there are 4 students. So every student got how many marks that we don't know here, right? So what we are doing? We are taking the mid value of that class, and that is nothing but the class mark. For every class we have done it. Here 15 is there, 25, 35, see 45 average of this class, 55 average of this class, correct? Okay. Now here fi xi. So this 4 into 5 we got 20 here. This one here 8 into 15 we got 120, and so on. Finally we did the summation of fi xi, which is 2145, and sum of all the frequencies 65. So here this formula of mean, substitute over there. So after substituting and dividing, we are getting the answer as 33. Therefore mean obtained is 33. Now remember once again, this method is the direct method to get the mean, right, for the grouped data. Now let us see the another method. Here, assumed mean method. Now here in this case, why we are using this assumed mean method? In the previous case, when the data is little in number, so direct mean method is a very good method. But as the data increases, our calculation will increase. That multiplication will become a little more tedious, and even the addition. There are chances that we may make the mistakes. That's the reason we are going to use the assumed mean method. In this one, a little less calculations will be there. In this, an arbitrary mean A is chosen, which is called assumed mean, somewhere in the middle of all the values of xi. So in the previous case, you have seen how to find out xi. That means the class marks. From there, one of the middle value we are going to choose, and that middle value is called as the assumed mean. Let us see the formula here. mean which is equal to A plus sigma fi di divided by sigma fi. Look at the difference here. In the previous case, xi it was. Now it is di. Di, it means that xi minus A. That means the deviation of that assumed mean from xi, from the observations. Okay. Now let us see this example, but we'll solve it by assumed mean method. See here. First column is same, second is also same as the previous one, third one is also same. Now look at the fourth column here. What we did, di equal to xi minus a. A already we assumed as 25. I said a you are going to choose from xi somewhere in the middle. So this exercise, see here, this one, this one, this one, this one, this one, any one value we can choose, but most of the time you choose the middle value, near to middle value. Okay, so here you can take 25 or you can take 35, any one value you can take. Okay, so I have taken it here 25 as the assumed mean. Now see here, xi minus 25. So all these values are x values, correct? So 25, this 5 minus 25, if we do, our answer comes as minus 20. Then 15 minus 25, if we do, our answer comes as minus 10 here. 25 minus 25, answer will be 0. Then here 35 minus 25 plus 10 answer. 45 minus 25 plus 20 answer, and 55 minus 25, our answer comes as 30 here, correct? Now the last column you see fi di, that means 4 into minus 20 we are getting minus 80. Then here 8 into minus 10, once again minus 80. This one here 13 into this 0 we get 0. 20 into this 10, 200. 12 into this 20 here, so it comes as 240, and 8 into 30, 240. Now here you see the addition of these two numbers comes as 1 minus 160, and addition of this number comes as 200, 680. From 680 we will subtract minus 160, so our answer comes as 520, and sum of all the observations is 65. Now this formula is formula to find out the mean by assumed mean method. We have to remember this formula, memorize it. So A already we said it is 25. Sum of FIDI 520 by 65. See, 13 5s are 65, and here 13 4s are 52. And this 0 is there. Then 5 1s are and 5 8s are. So 25 plus 8, we get 33. Therefore, assumed mean obtained is 33. Correct? Mean will be same. Only our calculation part is getting reduced. Let us see the third method now. Step deviation method. Here, once again the same thing. As the data will be very large, this method is very convenient to reduce the calculation part, to reduce the mistakes. Okay, look at the formula here. Mean is equal to A plus sigma fi ui divided by sigma fi into h. So here instead of di we have written ui, and one more thing into h. Now what is the meaning of ui here? Ui, it means that xi minus a divided by h, where h is a common divisor of di, or you can say most probably we take h as the class size. Okay, now look at this example. We will find out mean by step deviation method. Let us see the answer now. Here, class interval first column, frequency, then class mark, di as we did in the previous question. Now ui is what? xi minus 25 divided by h. Now in this case, what is our h? See here, h is class size. Take any class, upper limit minus lower limit. See, so h, which is equal to 20 minus 10, it will come as 10. Okay, or what they said, the common multiple of this di, these values, so which is coming as 10 only. Okay, here now this di we are having minus 20 divided by h. H is 10, so minus 20 by 10 comes as minus 2, right? Then once again, minus 10 by 10 is minus 1. 0 by anything will be 0 only. 10 by 10, 1. 20 by this one, 10, 2. 30 by 10, 3. Right? Our number become the simpler one. Now fi ui. See here, 4 into minus 2. It comes as minus 8. Here 8 into minus 1 comes as minus 8. 13 into 0 will be 0 only. Here 20 into 1, which is 20. Here 12 into 2, which is 24. And 8 into 3, which comes as 24. Now once again you see, sum of this minus 8 and minus 8, it becomes minus 16. And here 20, 24 and 24, these three values here. So 68. 68 minus 16. Our answer comes as 52. And sum of the frequencies 65. Correct? Now look at the formula here. This formula, A is 25. Sum of fi ui is 52. Sum of the frequencies 65 and into 10. Correct? Now once again, if you divide it by 13, so we get it here 8. So 25 plus 8, 33. Right? Therefore mean obtained is 33. It means that for the grouped data, you find out mean by direct method or assumed mean method or by step deviation method. You will get the same answer. Only what is the difference here? Difference is that your calculation gets reduced in each case, right? If one mistake will be there, that means the whole sum will go wrong. That's the reason we have just evolved this assumed mean method from the direct method, and even this step deviation method from the assumed mean method, right? I hope all of you understood what is mean and how to find out mean for ungrouped data and grouped data. Thank you.